Greetings and welcome, friends. We've been talking about angles and types of angles and names of angles and vocabulary, angle pair relationships, if you will. So here we go. Let's just go through these ones quick. I figured I'd just hit all of these. Name a pair of adjacent complementary angles. So complementary angles, right, add up to 90 degrees. Adjacent means that they are going to be having a common side and common vertex and have non-overlapping interiors. So it looks like these two right here, all right, those ones look adjacent to me, so I could call that angle LJM, and I guess I should say and rather than plus, because these are objects, not numbers, and MJN, all right. Let's see. Is there another one in here? How about these ones? Do you think these ones are? Nah, it doesn't look like those add to 90. And fortunately, in terms of drawn to scale, that also didn't look, bless you, by the way, didn't look like a 90 degree angle. But we can never go by what it looks like. So let's see. Name a pair of adjacent supplementary angles. That's when they add to 180 degrees. Adjacent supplementary, that's actually gonna... do you spot one? Right, yeah, so yeah, because these weren't labeled angle 1 and 2, I do have a way to name the entire kind of macro angle addition chunk there, so I agree that angle KJL and angle LJN would be also a linear pair. All right, if to use that terminology. Question, comment? Oh, I love it. Yeah, good catch. Good catch, yeah. So yeah, these two right here. Yeah, I'm not going to write it down. But yeah, KJP and NJP or PJN. Remember, the vertex of the angle has to be the middle initial for the three initial name. Name a pair of non-adjacent complementary angles. So non-adjacent looks like the 41 and the 49 are complementary and not adjacent. So I'll say FGE. G looks like a 6, but that's fine. And NJP. Anyone spot any others? 6 and then non-adjacent supplementary, that's probably this one and the 56, I'm guessing. Yeah, so FGH and LJM. Right. So that's those. Just a lot of vocabulary. Adjacent, non-adjacent, that means they're connected, share a common side with non-overlapping interiors. Here we go. Find the measure of each angle. These things are that's a right angle. By definition, it has a measure of 90 degrees. That's definition of right angle. And then by angle addition postulate, these two smaller angles add to it. And then by definition of congruence and substitution, I could say that 15x minus 2 plus 7x plus 4 is equal to 90. We could then combine like terms, and now it's just algebra from here on out. And you guys are my algebruddies. No, I'm trying to get that term going, but it hasn't. Community hasn't picked it up yet. I don't know why. Let's see, -2 and 4 like terms. I've been doing algebra lately with my algebra 1 class, obviously, and yeah, I love using the colors. I love it. Subtract 2 from both sides. Yeah, we've been talking about that in Algebra 1, why we shouldn't divide both sides by 22 first. You're going to create a bunch of fractions for yourself. It's still possible to get the right answer, but why trudge through the swamp of sorrows? Why go through a 4-day journey through the mines of Moria unnecessarily? You know what I'm saying? You know what I'm saying. I get x equals 4. They didn't ask for x. Oh, those... yeah, sneakers. Here we go. Let's now take the 4 and Let's find angle back. So the M angle BAC, that is now not referring to the object, the figure, the diagram. That is referring to a number representing the measurement of that angle. And I use equality to describe numbers. That's a way I can relate them. And let's see, so I'll have 15 times 4 minus 2. 15 times 4, that's what, 60 minus 2, 58 degrees is that one. And then I could just do the 90 minus 58. What's that, 32 degrees is the other one. So measure of angle CAD, or DAC, is going to equal 32 degrees. All right, so that's those two. Cruising. All right, ooh, here we go. Identify. So we had other angle relationships. Linear pair were two angles kind of back to back that were adjacent, whose non-adjacent, non-shared rays formed opposite rays. Basically, together they form a line. So they said identify the linear pairs that include angle 7. So here's angle 7, and so a linear pair with that would be 6, right? Because together they have they form a line right there. And then I also could have angle 8 because together those form a line with angle 7. So so I could say angle 8 works and angle 7 works. Sorry, thank you, 6. Man, with the save, you guys got my back. Appreciate it. Let's see, and then it asks the question, are angles 2 and 5 vertical? So here's angle 2. Is that a vertical angle with angle 5? They have a common vertex. No, I'm saying no. I'm calling bogus, baloney on that one. Let's see, angle 5 would be a vertical angle with the angle that is made up of both 2 and 3. Vertical angles form two pairs of opposite rays. So angle 2 and 5 at least had the common vertex, but they were missing the other piece. So no, they had a common vertex, but no two pairs of OP rays. Man, op rays. Right? That was a no-go, no-go. Let's see, I think I've got one more. There we are. I like this one. The measure of an angle is 9 times the measure of its complement. Question, comment. How'd you get that? 81 or not? All right, yep, so sometimes you can guess and check. But let's make sure we can logically argue that. You did make a good claim for yourself there. Because, yeah, sometimes the numbers don't come out as nice. So if I have angle, my angle is x degrees, I know that the other one is, the measure of my first angle was 9 times the complement. So my angle was 9x, the other angle was x. Or I could have said my angle was x and the other angle was 1/9 of x. But together, either way, they are complementary, so they add up to 90 degrees. So I'd have 10x equals 90, divide both sides by 10, I was going to say 9, and I end up getting x equals 9, as we had said. So that is the measure of one of the angles, and then the other angle, its complement, would be 81 degrees. Well done, well done. I could call that y if I wanted or something like that. But so thanks for watching, internet friends. Tienen un día más bien del mundo.